Before we get into the demonstration, just a few words on what iTM is and is not. iTM stands for Intelligent Test Method. Many people ask what the intelligent part of Intelligent Test Method actually means. Well, my answer is that it's intelligent to use a properly defined and managed test process, and it is very unintelligent not to. iTM is an organization's test process repository. In other words, the support environment for the organization's test process database. More than this, though, it's the test process database itself. This means that the documents held in iTM are the procedures, templates, tools, and guidance for the test process. iTM is a configurable and customizable software testing framework presented in the form of a self-contained and easy-to-navigate website. It consists of several process diagrams containing links to guidance, templates and tools that are designed to help set up and run an efficient and, perhaps more importantly, an effective test process. Note that iTM is not a file management system. This means that it doesn't provide the ability to save and retrieve the operational documents created for individual projects. Why is this? Simply because most organizations will already have their own preferred methods of storing project documentation and will wish to continue using the tools and data structures they are comfortable with. There may also be issues with security for some organizations when using cloud-based storage or shared repositories. So iTM lets the individual organization and even individual projects decide for themselves where they will store their operational artifacts. So with all that in mind, let's have a look at iTM. iTM contains testing frameworks for two software testing methodologies, Waterfall or vModel and Agile. To begin with, let's look at the vModel method. Throughout iTM, there are diagrams representing process flows. These diagrams contain live links which, when selected, navigate to the relevant guidance for the selected operation. The Waterfall or vModel method is comprised of four main phases: test planning, test specification, test execution, and test closure. Let's have a look at the test planning phase. Using this process diagram, we can see some of the common features of iTM. Firstly, the main process flow runs from top to bottom in the middle of the page. Each activity or decision point is numbered for ease of reference. Inputs to the process are shown on the left in light red, and outputs are to the right in green. Each of the elements of the diagram are linked to descriptive text, which explains how to carry out the relevant procedures. So, selecting TP10, entry criteria met, the explanation of this procedure is displayed, which in this case contains further links, including one to the entry-exit criteria checklist. Against some procedure elements, there are touch points of varying types. A validation touch point, a V in a red circle, indicates that at this stage of the process an important decision or check must be made. Selecting the validation icon displays the description. For TP10, the validation is that a check is carried out to ensure that all entry criteria have been met. Tool touch points are light blue rectangular boxes containing a reference to the tools used at this point in the process. Again, using TP10 as an example, selecting the tool touch point presents the list of tools from where either the full tool set list can be opened or the test monitoring and reporting tool itself. Selecting the Waterfall toolset spreadsheet displays the details of the test tools being used in the organization. T31 is listed as the test monitoring and reporting tool. The spreadsheet is configurable for the actual tools used by the organization. There are also metric touchpoints, yellow rectangular boxes containing the identification numbers of the metrics collected or associated with a procedure or deliverable. Using TP10 as an example, selecting the metric touchpoint presents a table containing all metrics collected or used in this phase, test planning. From where can be selected individual metrics, say M1. Now, the full definition of this key performance indicator is displayed, including its objective, how it is calculated, and the defined thresholds, in other words, what levels are expected to be achieved. Finally, for touchpoints, there are responsibilities touchpoints, which, when selected, allows the opening of a matrix documenting a standard set of roles involved for each of the main test process activities. This matrix is configurable for the organization. The main process diagrams also contain links to inputs and deliverables. For example, one of the inputs to the Establish Test Strategy activity is the Organizational Test Strategy, which itself is based on the test policy. Both the Organizational Test Policy and the test strategy are configurable. One of the deliverables is the Product Test Risk Catalog, which provides the ability to report risks graphically in several ways, including how the product risk varies over time and how effective mitigation has been at reducing risk. There are several tools available in iTM. One of these is the test estimation model, which is particularly relevant to the test planning phase. This tool enables you to set up parameters for a project, to enter assumptions, and to create high-level estimates from basic data. The tool is highly configurable, and there are detailed instructions available for its use. The test planning phase process diagram also provides access to templates and guidance to help in the production of project test strategies and test plans. As well as for test planning, there are similar process diagrams, guidance, and tools for the other phases: test specification, test execution, and test closure. Sitting on top of the four main phases of testing, iTM also has separately defined processes and associated guidance for handling product risk and for test monitoring and control. There are also several ITIL-based processes: incident management, configuration management, change management, and requirements management, and processes directly related to the TMMI framework, such as test process improvement, reviews, and defect prevention. All of these procedures come with full guidance. I talked briefly about metrics and demonstrated how iTM indicates what key performance indicators are collected and where in the testing process through the use of metrics touchpoints. I also showed how iTM defines key performance indicators. But how are these metrics captured, calculated, and reported in iTM? Testing organizations that already have a defined and operational collection and reporting system can, of course, continue to use what they have. Their own KPI definitions and targets can replace those that are predefined in iTM. But for those who do not have an established metrics setup, iTM provides a metrics tool which enables projects to collect data for and report on up to 26 key performance indicators. Data can be stored and analysed covering the whole of the test process lifecycle, from requirements definition and test preparation through test execution to live operation defect management. There are several predefined graphical and tabular reports available for each of the test phases, including requirement stability, test preparation progress, test execution progress, total test effort, defect status, defect detection and fix statistics, and defect aging. Ultimately, all data in the tool feeds into the dashboard, where a summary of key performance indicators provides an easy-to-understand view of the overall state of testing. One particularly useful report shows defect leakage, comparing the numbers of defects introduced into a product and where they are detected. By entering estimated costs of defect resolution, it's possible to generate reports of the overall cost of poor quality and how this may be reduced by detecting defects earlier in the development lifecycle. All graphical and tabular reports can be copied into daily or weekly test reports or closure documentation. Data can also be imported into the metrics tool from other defect management tools such as ALM, Jira, or Azure. This can be useful to help identify inconsistencies in existing defect databases and provides an exemplar of what a useful reporting system can look like. The metrics tool is designed to provide key performance indicator information for individual projects. But if there is a need to measure test performance across projects, say for a program, a department, or even the whole organization, this can be achieved by using our predefined Microsoft Power BI templates, specifically designed for reporting test lifecycle data. Now let's have a look at the iTM Agile methodology. For organizations that are just moving or thinking of moving to an Agile paradigm, the base iTM Agile methodology provides a good place from which to start. For those who already develop using an Agile methodology, iTM provides structure and guidance for embedding testing into projects or for running independent testing in parallel with them. Note that iTM Agile testing is not a full Agile development methodology. This is because the choice of specific Agile techniques is dependent on the particular needs of the products under development and the tools available, and these choices are best left to the local Agile development experts. Having said that, iTM Agile testing is a framework for testing in an Agile context and explains not only how testing can and should be part of the development process, but also how independent testing can be included in Agile projects. So the iTM Agile process also describes Agile development using a hybrid of the many available flavors of Agile. The main methodology on which iTM relies is Scrum, but with the inclusion of a number of techniques from other Agile methods including Kanban, and with recommendations for particular development techniques such as test-driven development. These recommendations are based on the most effective techniques found most frequently in recent Agile houses that Experimentus has encountered. The principal process of iTM Agile is appropriate for all domains and all levels of risk. The basic framework, risk assessment, and general approach to testing and monitoring and control will be useful for all projects. Organizations must, however, ensure that the test techniques, test levels, and test types, and the relationship between them are defined according to the particular needs of a project. One of the tenets of Agile is that it is flexible. Even within the same organization, there may be a need for a number of different implementations of Agile, and the Agile strategy can be adjusted accordingly whilst still maintaining the same iTM recommended control and reporting mechanisms. As far as the iTM Agile process is concerned, in principle, the documentation is similar in form to the Waterfall methodology, with process flows linked to guidance. In addition, though, there is a training package, Introduction to Agile, based on the ISTQB Certified Agile Tester Syllabus, which provides information on topics including different types of Agile methodology, working with user stories, planning and estimation, specific test techniques, and Agile progress reporting, monitoring and control. As an option, iTM can also be supplied with training based on the latest syllabus of the ISTQB Foundation course in software testing and additional advanced training. In summary, iTM provides an easy-to-install, easy-to-use and configurable testing framework suitable for any type of product, any level or type of testing, and any size of test organization. The benefits of using iTM include that it provides full documentation of the test process, it's a centralized and controlled location of test process assets, it provides access to comprehensive process maps, procedures, tools, templates, checklists, and guidelines created by some of the most experienced individuals in the testing industry. It comes complete with a suite of predefined targeted metrics. It can be used out of the box or customized. It can be employed in full or used selectively to fill gaps in an existing test process. And for those who are undergoing test process improvement using the test maturity model integrated, it is TMMI Level 5 compliant. Thank you for watching this introduction to iTM. You can obtain more information by going to the Experimentus website, experimentus.com, or by emailing info@experimentus.com.